Khan Academy sent me an email today because it was my birthday, and they sent a link to the birthday problem, which is basically the question: in a class of 30, what's the probability that two students have the same birthday? And Khan Academy solved it using factorials. Well, I'd like to look at this problem a little differently and use simulation and expand the question to what's the probability that we have one pair, two pair, three pair of students that share the same birthday. So let's develop a simulation model using SIPmath that solves the problem. So here's the birthday problem model, and I've described the problem up here as being that of what's the probability out of a class of 30 students that someone shares a birthday with someone else. So what I did was to generate 30 students. And then I generated a random variable, a uniform random variable between 0 and 1 using SIPmath. And then I simply calculated what day of the year would that birthday occur for that student 1. So I simply took the random variable D16 times 365 and rounded up. That means that the values could be from 1 to 365. And I did that for 30 students. Then I asked the question, let's come down here, count if in this list the value 21 is repeated. And here we can see that there's one repeat. So that's right down here in row 37. Then I simply added up how many matches we had. Well, in this particular simulation, we had 6 matches. What does that mean? That means we had 6 pairs. Now that's a random variable. It has a distribution. So what is the distribution? The distribution looks like this. It says there's 27%, I guess actually 29%, because I'm going to compute that up here, 29% chance that there are no matches. No one shares the same birthday. And then there's a high probability of, it says 2 here, but it's really 2 because, as we saw above, if 2 people shared the same birthday, I counted 2. We could probably need to divide by 2 if you really want to think about it that way. And then there's a chance that there's 2 pairs, 3 pairs, 4 pairs. As I've used the chance of whatever down here command. This is SIPmath chance of whatever to generate this equation, which simply asks the question: how many people actually did that random variable actually have a value of 6? And there were 8% of the time it had a value of 6. And as we talked about, there was a 29% chance that there was 0, so no matches. And I plotted that distribution here. An interesting observation here is what's the chance that 3 students share a birthday? And the answer would appear to be very, very small. Because if there were 3 students that shared a birthday, then I would have gotten an odd answer here. I would have gotten a 3, for example, if there had been 1 triplet. And since I don't seem to have any odd numbers here, I'm assuming that a triplet is very unlikely. Hope you found this video of use. Thank you for watching. If you're interested in learning more about SIPmath, you can go to www.probabilitymanagement.org, and you can download the SIPmath toolbar over here at Tools. You can download either the PC version or the Mac version.